Today we're going to talk about parallelograms. And the first thing I want to say is there's a lot of theorems that I'm going to throw at you right at the beginning here. And I do not expect you to remember what they're called. I just want you to be able to use them to prove something's a parallelogram or to use them to solve for missing pieces and parts of a parallelogram. So the first theorem tells us that the opposite sides are congruent. So this is the most important part right here. The opposite sides of a parallelogram are congruent. Okay. The next one is that the opposite angles are congruent. Okay, and so again, I don't expect you to remember what those are called, but you do have to know that, like, so this angle and then the one across from it are the same, and this side and then the one across from it is the same. They're congruent. Okay. The next one is that the consecutive angles are supplementary. Okay, so the consecutive angles mean the angles that are right next to each other, or the ones that would be like same side interior angles, is kind of what we called them when we were talking about parallel lines. So like this angle and this angle added together would equal 180 degrees. Okay, so then we have the parallel diagonal theorem, so that the diagonals bisect each other. Okay, so what we're saying is that M here would be the midpoint of line PR, and M would be the midpoint of QS as well. So we can use that if it's being bisected. We know it's a parallelogram, or all parallelograms have that property. Okay. Last ones here is the converse. So if you have two sets of sides across from each other, or opposite sides that are congruent, then it is a parallelogram. So if opposite sides are congruent, then it's a parallelogram. Okay? And if opposite angles are congruent, then it is a parallelogram. So like if these angles and then also these angles are congruent, that means it's a parallelogram. Okay? So what we're going to do, a couple more. Same thing for these. These are just the converses. So we're saying if these are parallel, these two lines, and congruent, parallel and congruent, so congruent and parallel, then it is a parallelogram. And if this point here, we'll call it M again, is the midpoint of AC and it is the midpoint of BD, then ABCD is a parallelogram. So then this shape is a parallelogram if that's the midpoint, okay? So we're going to look at this one and we see that, oh look, it's a parallelogram because we have two sets of parallel sides. And we know parallelograms, opposite sides are congruent, so I can just set the opposite sides equal to each other. So x plus 4 equals 12, so x equals 8. And then I also know that y is equal to 65 without doing any work because opposite angles of a parallelogram are congruent. Okay, we can use the same idea on the next one. This side and this side are opposite sides, so they're congruent or the same. So we can set them equal to each other. So we know that y is equal to 15. Okay. And then we know that opposite angles, so this angle and this angle would be congruent. So 2x equals 50. So x would be equal to 25 degrees. So we're just using the fact that we know opposite sides and opposite angles are congruent to solve for missing pieces there. Okay. So what I would like you to do is pause right now and graph these 4 points, L, M, N, O, and I'm going to do the same. Okay, so now I've graphed the intersection of the diagonals here, I've graphed the parallelogram, and so now I want to find the intersection of the diagonals. So this is the parallel diagonals theorem. And so we know that the diagonals of a parallelogram bisect each other. So what we need to do is just find the midpoint of one of them. So we can find the midpoint of MO or of LN. I'm going to choose to find the midpoint of LN just arbitrarily. So I'm going to use a midpoint formula. So 1 plus 6 over 2. Remember, we just add the x's and add the y's. 4 plus 0 over 2. Sorry, that's cool. So then I have 7 over 2, and then 4 over 2, which is 2, and I'm going to turn it into a decimal here just because I want it to reflect like this point is, yes, it is about at 3.52. So that would be the midpoint there. And so we know that this is where the two diagonals bisect, the midpoint. And if you found the midpoint of MO, you should get the same answer. Okay, I'm going to have you pause it again and graph WXYZ on this graph. Okay, now that you've graphed the three vertices that we know, we want to find the coordinates for Y, which we know is going to be in between X and Z. And so we can use a number of different ways to figure out where this is. I think the easiest is to know that a parallelogram has two sets of parallel sides that are congruent. And so I can figure out the distance and the slope between W and Z and then use that to find Y. So I see that this goes down 1 over 5. So I can go down 1 over 1, 2, 3, 4, 5. And put point Y right here. Okay? 2, 1. And so I could have also done this and gone down 1, 2, 3, 4, 5 and gone over 1, 2. And done the same thing and gone 1, 2, 1, 2, 3, 4, 5, and it would have gotten me that same other vertice. But what we have to remember is that this is a parallelogram, so all the sides are parallel and congruent. So that means those are the same and these are the same. Okay. All right. So now we're going to use the fact that we know that if this is a parallelogram, then it needs to have diagonals that bisect each other. And so we know again that this would be the midpoint of both of the diagonals, which would be point N. And if it's the midpoint, then we know this side and this side are congruent. So we can set those equal to each other and find the value of X that would make that a parallelogram. So I'm going to subtract 5x from both sides and get negative 8 equals negative 2x. Divide by negative 2 and get x equals 4. So I know that x equals 4 is the value that would make that a parallelogram. Okay? We're going to do the same thing here using what we know about the angles in a quadrilateral that is a parallelogram. And that means that angle B and angle D would be congruent. And angle A and angle C would be congruent. So I'm going to set up two equations. The first one is going to be 3x minus 32. It's angle A. I know it's congruent to the opposite angle, which is 2x, angle C. And I also know that y plus 87 is equal to 4y because angle D and angle B are congruent as well. So I can solve these both and get that y is equal to 29. And I can solve this one here and get that, so I get negative 32 equals negative 1x, so x is equal to 32. Okay, and those are because we know the opposite angles are congruent, so we can set them equal to each other. Okay, we're going to do the same thing here again. We know that opposite sides of a parallelogram are congruent. So we need to figure out what would make these sides be congruent, what value of x and y. And the first thing I see is that this side has a y and this side has an x. And so I need one of those values before I can find the other one. And I see that this side, PQ and RS, both have x's. So I'm going to solve that one first. So I'm going to set x plus 9 equals to 2x minus 1. And again, that's because I have x as a variable in both of those. And then once I have that x, I can use it to help me find y. But I want to do that x first, otherwise I wouldn't be able to solve for y. So if I do this, I would get 10 on this side and x over here. So I know x is equal to 10. Then I know that y is equal to x plus 7. But now I know that x is 10. So I know y is equal to 10 plus 7. So y is equal to 17. So these are the values, because we know that opposite sides are congruent, that would make this parallelogram, or this quadrilateral parallelogram, so that all the sides across from each other, or opposite sides, would be congruent. Okay, so Again, I'm not going to ask you to know the specific names, but I want you to be able to identify why this is a quadrilateral. So I know it's a quadrilateral because the opposite sides are congruent and the sides are parallel. So congruent sides, one set, and parallel, okay? This one, I'm not told that they're parallel. I'm just told that these sides, the opposite sides, are equal, okay, on both directions. And so we know opposite sides are congruent. Two sets of opposite sides are congruent. So I know that that is a parallelogram, okay? This one, I notice that this angle and this angle are congruent, and this angle and this angle are congruent, and so those are opposite angles that are congruent. So two sets of opposite angles that are congruent. That's why I know that is a parallelogram. Okay? All right, so this last one is another graph. So what I'm going to say is that there's 4 different things you could do to show this. We could show that the opposite sides are parallel, because if you have 2 sets of parallel sides, that's a parallelogram. I could show that one set of sides is parallel and congruent, okay? That would be another way to show it. I could also show that the diagonals bisect by showing that they have the same midpoint, okay? Or I could show that the opposite sides are congruent, so I could have 2 sets of opposite sides being congruent. I have put the work for all 4 different ways on the filled in notes, but I'm only going to show you one out of respect for your time because it's pretty time consuming to do it all 4 different ways, okay? So I think I'm going to just show that we've done a lot with midpoints, and so I feel like you could find the midpoint of AC and find the midpoint of BD on your own and find that those are the same midpoint, and that would prove that that's a parallelogram. I'm going to choose to show that the opposite sides are parallel. So I'm going to find the slope of AD, which is down 3 over 3. So negative 3 over 3, which is negative 1 as a slope. And then I'm going to find the slope of the opposite side. So of BC, also negative 3 over 3, which is, so these are parallel. So AD and BC are parallel. And then I need to show that these sides, AB and CD, are also. So I'm going to go up 2 over 1, 2, 3, 4, 5. So AD, the slope is 2 over 5. And BC, up 2 over 5 also. So I know that these two are also parallel. And so because they have 2 sets of parallel sides opposite each other, then it is a parallelogram. Again, there's 3 other ways you could do that on the graph, and I have showed that on the notes, and it would be a really good idea to at least look through those so you're aware that you can do use all those different theorems to prove that ABCD is a parallelogram. Please look over the notes and then complete the assignment for today and let me know if you have questions.